All right, hey guys, it is Wednesday. Um, Make sure you hit the right button there. Cool. Hey, it is Wednesday, so I'm actually making this video Tuesday night. We had 3 people do Tuesday morning chemistry live, so that's fine, but that means I should have 74 of you doing it Thursday afternoon. Okay. I doubt I'll have 74, and that's okay, but don't forget about Chemistry Live. So I'm not going to spend a lot of time on that, but in essence, what we did on Tuesday morning, for those who were there, and this will happen Thursday afternoon for the rest of you, is I kind of started a lab on Kool-Aid concentration. So when you make concentration, we did the pre-lab part. We did a few different parts of it. Now, before we're ready to actually do the lab, we got to talk about something called molarity. So what I'm going to talk about today with you guys is this idea of molarity. And again, we're not talking about the brown furry animal. That's not the mole we're talking about. We're talking about Avogadro's number, right? 6.022 times 10 to the 23rd, a really big counting unit. But molarity is a way that we can measure concentration. So remember, we've been talking about concentration of solutions. There's concentrated where there's a lot of solute. There's diluted where there's not much solute. And solute is a word you should know. Solution is a word you should know. We've talked about percent by mass. We've done percent by volume. We've talked about parts per million. The big one I want to get to, and this is the big one, is molarity. This is something in chemistry we use all the time. All right. It's a big deal. Molarity matters. What is molarity? Here it is. Okay. Molarity is the number of moles of solute in 1 liter of solution. So remember, solute is the thing that gets dissolved. So in this picture here, right, it's the green stuff. I don't know what this is. I'm going to assume this is some kind of copper, probably copper nitrate, being dropped into a dissolver. That's the solvent. This is the solute. So molarity is how much solute is in the solution. Remember, solution is the diluter with the diluted. So when I put them together, I get the solution. So what is the concentration? How much of the solute is in the solution? That's molarity. That's what we're going to talk about today. And it matters. You can express it by moles per liter, okay? But in chemistry, when we have chemicals, you have to identify how strong are these chemicals. Okay, if I have an acid, if I have hydrochloric acid, there's some hydrochloric acid I have back at school that if I took it and I poured it into my hand, it would literally burn a hole through my hand. Okay, it's what's called 10 molar, 10 capital M, and that molar is back to this capital M here, it's molarity. Well, as you look at the different chemicals, I have potassium hydroxide, but it says 0.8 M. Potassium chromate, 0.08 M. Potassium chromate again here, 1 M. That is the molarity. That's telling me how concentrated, how strong is it. So this idea of molarity, this is a way to express concentration, right? So that's a really big thing, and that's what I want to get across to you today, okay? Now, I'm going to push pause there. In Google Classroom, I posted the molarity problems, and it's going to go through, I think there's 9 problems. I'm going to go through them quick. You guys can fill them in, turn them in. That's your notes for today. You don't have to write down this or take notes or all you have to do is go through the problems. It starts right here. I'm going to go through it kind of quick. If you have questions, doggone it, ask. I'd love to help you. Okay, here we go. So the first problem says, what is the molarity of a solution of sodium hydroxide if there are 4 moles of sodium hydroxide dissolved in water to make 1 liter of solution? So remember molarity. Molarity is moles over liters, 4 over 1, 4 molar. Done. That's it. The molarity is how much of the dissolved, and dissolved, remember, is the solute, over how much of the solution, okay? That's sodium hydroxide in water, 4 over 1, moles over liters is capital M, which stands for molarity. That's it, okay? Now, they're not always that easy, but that's it, okay? Here's another one. Same exact question, but now it says 4 moles in 2 liters. What do? Well, I take what's dissolved, the solute, right, over the solution. That's 4 moles over 2 liters. 4 divided by 2 is 2 molar. Done. That tells me the strength. That tells me the concentration. By the way, 2 molars is less strong, less concentrated, or more diluted than 4 molars. This one is stronger, more concentrated than this one. Okay, 4 molar is stronger than 2 molar. Let's do another one. I know I'm going quick. Same thing. 2 moles again. Now I have 6 liters. The dissolved over the solution. Moles over liters. 2 over 6 is a third, or 0.33. 0.33 molarity, 0.33 molar. That's the least strong, right? So hopefully you're making sense. You mean you just take moles of what's dissolved over liters of how much you got? That's it. Okay. What if I had 0.5 liters? Moles over liters, 2 divided by 5, 4 molar. Okay. So hopefully this isn't too complex, too complicated, but I want you to understand what's going on here. Okay. Now, here's another way to look at it. It says, what is the molarity of a solution of sodium hydroxide again if there are 40 grams of sodium hydroxide dissolved in 1 liter solution? So most you're going, yeah, sweet, I can do that. 40 over 1, it's 40 M. Wrong. Why is that wrong? Because if I go back, it's not grams, it's moles. So if you're given, like we are in the first few problems, if you're given moles and you're given liters, it's easy. If you're given moles and you're given liters, it's easy. But now look at this one. I'm not given moles. I'm given liters, which is on the bottom, but I'm given grams. So what I have to do is I have to convert grams to moles. Okay, well, how in the world do I do that? Well, remember doing molar mass trimester 2, right? I have to look at what I got. So I go, all right, well, sodium, remember at the bottom of the box in your periodic table, sodium is 23 grams in 1 mole. Oxygen was 16 grams in 1 mole. Hydrogen is 1 gram in 1 mole. So if I find the molar mass of sodium hydroxide, it's 40 grams in 1 mole. The molar mass is 40 grams per mole. So how many moles do I have? If I have 40 grams, I have 1 mole. Well, now I can do it. Now I just go moles over liters, 1 over 1. My answer to that question is 1 molar. Okay. And I know that's a lot. I know your head is swimming a little bit, and that's okay. We're going to work through more of this on Friday, but I just want to show it to you today. Okay. What if I have 80 grams? Still 1 liter, 80 grams. Well, same thing. It's still sodium hydroxide. I can go back. I know sodium is 23. I know oxygen is 16. I know hydrogen is 1. I add those up. I get 40 grams per mole. But now what's this say? This says I have 80 grams. Okay, well, 80 grams and a 1 mole is 40. So 80 is twice as much as 40. I must have 2 moles. 2 moles over 1 liter. My concentration is 2 molar. And I'll show you how to do that more mathematically on Friday, but I just conceptually wanted to see you understand this. Okay? And here's another one. Same thing. It's still sodium hydroxide. So my molar mass is still 40 grams per moles. Okay, so 3.6 grams divided by 40 is 0.09 moles. Now I can take moles and put it over liters. Ooh, it's not 2, or excuse me, it's not 1, it's 2. So 0.09 moles over 2 liters. Do that math, 0.045. Okay, so the big picture is molarity helps us understand concentration. By the way, if the concentration is less than 1 molarity, we consider it weak or dilute. If the concentration is greater than 1 molarity, we consider that strong or concentrated. And so if we're doing a lab, and I don't know if we'll get back to school to do one, I sure hope so, but if we were doing it and I said, use hydrochloric acid, you need to look, well, what strength? Do I want to use the kind that would burn through my hand, or do I want to use a much lesser? If we're doing it in a lab in high school, it's probably going to be less than 1 molar, because greater than 1 molar is pretty dangerous. It really is. But it matters. The concentration matters. The molarity matters. Okay, so you have what you need. That's all I want to do for today. I wanted to go through those questions. Hopefully you're writing along with me, and maybe you're saying, Mr. G, I don't totally understand it. That's okay, but I hope you understand molarity is expressed in a couple things. Hopefully you see, and I'll talk about the triangle on Friday, but hopefully you see that molarity is moles over liters. Hopefully you see it's a measure of concentration. Okay, it's a measure of concentration. That's all I got. Remember, tomorrow, Thursday, we got Chemistry Live for 1 o'clock for the rest of you who didn't make it on Tuesday morning. Okay, love you guys, miss you guys, can't wait to connect. If you need any help, if you have questions, email me. Remember, you can get me. I have open office hours. You can do the Google Hangout. We can share screens. I can talk through it with you. A number of you guys have done that. I know it's intimidating to do that first, but you can do it. That's all I got, guys. All right. We'll talk to you later. Peace. I'm out.